MMA.
Okay, so just to let everyone know that I have turned on the recording, just because we're going to start in a few minutes, and I wanted to make sure that we were good to go.
Great.
It's been a couple months since I've done this, so there was a little anxiety on my part to make sure that I remembered.
You got it. You got that part down. So congratulations.
Okay, I found who it was. So this is from a year ago. It was a field guide to the seaweeds of Maine.
Oh, right. So that was Jordan Chalfant.
Yes, it was.
Yeah, she's phenomenal. Yeah.
I was like, whoa. It was a lot. And it was amazing the intricacy, I will say, of the research. And yeah, it's a whole world unto itself.
I could say to you and to anyone else who's listening that she and Amanda Savoy are going to be offering a class on seaweeds at Eagle Hill next summer in early June, which I took last summer, and it was phenomenal. And so anybody who's interested in seaweeds more than just superficially should look into that.
Where could they look into that?
EagleHill.com.
EagleHill.com. All right,
Oh,
wonderful.
sorry, eaglehill.org. Right.
Okay. EagleHill.org.
They have a lot of different natural history courses all the time, so they're pretty amazing. I'm going to try to go to that seaweed one next year. Yeah. David keeps reminding me, so I won't forget. I'm good at identifying rockweed. A few other things.
Right. There's more to seaweed than just rockweed, but you may not come away from this afternoon realizing that.
Yeah.
So according to my clock, we've got about 1 more minute before we get underway. Usually what happens is we have a few late joiners, so hopefully they'll join us during the intro. Like I said, probably in about a minute or so, we'll officially start.
Good.
Perfect.
All right, I looked the website up and it's eaglehill.us.
Oh.
And I'm dropping that. Oh, I guess I can't. Can I send it to everyone? Let's see. No, I can't send it to everyone, but I have it written down and we can remind folks at the end.
Okay. Okay. So I have it as 4 o'clock on my end, so we're going to get underway. My name is Beth Dickens, and I am from Blue Hill Heritage Trust. And I am stepping in for Marin this week, who is doing some much needed work on building his house, hopefully before the cold weather comes. So he's taken a few weeks off. So thank you very much for having me today. We are here to present our Friends from the Field webinar, Seaweed, a Vital Resource and Habitat. And we have David Porter and Allison Snow with us today. David Porter lives in Brooklyn and is a retired professor of mycology and botany from the University of Georgia. And Allison Snow is of Brooksville and is a retired professor of botany and ecology from the Ohio State University and is an adjunct professor at UMass Amherst. And so now I'm going to turn it over to Noelle, who's got some housekeeping stuff, and then we will be able to get underway. Take it away, Noelle.
Thank you, Beth. Thank you, everyone, for being here. So excited to learn about seaweed. Um, if any questions come up for you during today's presentation, feel free to use the Q&A feature. It's on the bottom of the Zoom screen. You just hit Q&A and you can type in your question, and then we will answer those questions. Well, I won't. David and Allison will at the end with whatever time we have left. And I also want to point out that at the bottom of your Zoom screen is a show captions button, and you can click that. There, it's a CC is what you'll see there. And you could click that if you're hard of hearing or if you just want to be able to read what the presenters are saying as well as listen. All right. Thank you.
Okay, David, I'm assuming you're up first, so if you'd like to take it away. Thank you very much for joining us today, and we look forward to hearing what both you and Allison have to say.
Thank you. Thank you, Beth at the Blue Hill Heritage Trust and Noel at Island Heritage Trust for allowing us to share our interest and enthusiasm for rockweed and for other intertidal and subtidal seaweeds that we've been concerned with and have been studying. I'm going to share my screen now to get a PowerPoint presentation started. Let me know if that shows up and if you can see that.
It's showing up, looking good.
Okay. And so I'm going to use the little view screen in the upper right-hand corner to reduce the images of speakers, because that's not necessary. What I want you to see is the slides from the PowerPoint presentation. So thanks again. Allison and I would like to present this this webinar on seaweeds and tell you something about why it's a particularly special habitat along the coast and why it's a vital resource for us to be concerned about. Alice and I are both co-founders of the Blue Hill Peninsula Rockweed Forum, and our website is listed there, rockweedforest.org. And at that website, you can find out more about what we're doing as far as our mission of advocacy for the conservation of intertidal rockweed. That's Ascophyllum nodosum. And at the website, we have available at the website news articles and information about harvesting, ongoing harvesting, and some of the legal issues that surround harvesting, but also some of the biology of the rockweed plants and other seaweeds. And we've even got some rockweed-inspired art that we have on the website. We're going to divide this talk into two sections. And the first section, I'm going to be talking about seaweed biology and the ecology and some of the associations of these seaweeds with other organisms, and also some of the commercial uses of particularly rockweed and also kelp. And the second part, Allison's going to be focusing more on the effects and the extent of harvesting of, in particular, rockweed. So we'll each take about 20 minutes and then have time for questions afterwards. And those questions, as Noel said, you can put in the chat at the bottom of the screen there. Well, we should start off with trying to identify what, in fact, is a seaweed. Seaweeds, we can say, are marine algae which grow at the edge of the sea. They are attached for the most part, and they are photosynthetic, but unlike plants, they are rather simple in structure. They don't have any roots or leaves or stems, instead, whoops, sorry about that. Pushing too many buttons there. We'll come back to that. Instead, they have an anchoring structure called a holdfast, and this is what I'm trying to do, and a stipe, which is like a stalk that holds up the blade of the seaweed in the water column to help it with photosynthesis. And this is a kelp that you can see those structures, the holdfast and the stipe and the blade, typical of most seaweeds. There are different kinds of seaweeds. They're based on their pigments. They're reds and greens and browns. Today, we're going to focus on just the larger brown seaweeds, including kelp, especially Saccharina latissima, sugar kelp, bladderwrack, to some extent, which is different species of fucus. Here's some right here. And in particular, rockweed or Ascophyllum nodosum, shown in this picture also, which is the dominant intertidal brown seaweed that we're particularly concerned with. Let's start with kelp. Kelp is particularly significant in seaweed aquaculture because it grows so quickly. Here is an annual growth of kelp. These individual kelp fronds here are about 6 feet or so in height. You can tell by this measure of this person holding up the kelp here, and that rapid growth can then be harvested after a very short period of, relatively short period of time, after 6 months or so of growth in the field. Different kinds of kelps can be grown as aquaculture. Here's a horsetail kelp, Laminaria digitata or Saccharina digitata, in a tide pool here, and another illustration of the complicated holdfasts that keep these kelps attached to the substrate that they're growing on. Kelps are often found in the near subtidal, and at very low tides can be seen in the low intertidal, often in very high energy shorelines, such as you see here. But they can also grow in calmer areas, and here's one that's a good 6 feet tall. Notice the dark patch in the center of this kelp blade. That's where the next generation of kelp is being produced. The spores from this kelp are produced in those patches, and they can be harvested actually and grown commercially and then inoculated on long strings. And so an aquaculture facility can put out these long strings of kelp, as indicated in this Atlantic Sea Farms photograph, and in a matter of 6 months or so can grow up to be the height of 2 meters or so and harvested for commercial uses. Kelp forests, I have to say, are worldwide in cooler temperate regions, and they are the habitat for many species of invertebrates and fish, sea urchins, sea stars, lots of fish species, and so on, including lobsters and scallops. And I have to point out that there was a wonderful program recently that was put out by Nova on the PBS channel about Cassius Ledge, which is a seamount in the middle of the Gulf of Maine, where the diversity and spectacular array of different organisms in this kelp forest on Cassius Ledge has been documented recently, and that's some wonderful video photography of Cassius Ledge. I recommend it to anyone who hasn't already seen it. I suspect that many of you probably already have. There are kelp forests, as I mentioned, all around the world. Some of the best known ones probably are those in the Pacific Northwest. These iconic kelp forests are different from those that we have in Maine. The plants that are there, the kelps that are there, are much taller than ours, and they're often raised up by large air-filled bladders to hold the fronds up in the photosynthetically lighter areas of the subtidal. In the Northwest, there's a long concern about the kelp forest because they're being threatened by sea urchins that are grazing all the young kelp plants, and the fact that the sea otters are in decline, which themselves harvested the sea urchins, and there's an interactive web of different organisms there that are necessary to maintain the kelp forests. I can do this. So kelp aquaculture, as I say, is a sustainable activity, and lots of the kelp products are diverse and have been used for a variety of things. This is just an example of some of the products that you can buy locally that are made of sugar kelp, for instance, and some of these fast-growing brown seaweeds. But today I want to also emphasize the intertidal brown seaweeds, those that are not below the low tide line, but that are in this remarkably stressful intertidal region where in the summertime you have great heat stress and also salinity stress in this region. And this region is dominated by rockweed and to a certain extent by bladderwrack, the species of fucus. Here you can see both of them again in another picture, the bladderwrack with lots of little receptacles all over the branches here, and the narrower branches of the rockweed or ascophyllum. Fucus vesiculosus, the most common fucus species, is characterized by having these little air bladders that are able to help raise the seaweed up in the water column as the tide rises. Rockweed is, when it's full grown and when it hasn't been dramatically harvested, forms these forests that you can see with a canopy on the upper regions and stalks of clumps of fronds that hold this canopy up in the water column. This kind of habitat is very conducive for sheltering all sorts of fish and invertebrates of various sorts. It's a rich, biologically diverse habitat at the high tide, where various swimming creatures can find shelter there. But it's also an important habitat at low tide when it offers a cooling and a moist blanket over the potentially hot and drying intertidal area. So that underneath this vast stretch of rockweed, we find all kinds of sheltered crabs and mussels and barnacles and many other invertebrates and so forth. The rockweed itself, as I mentioned, is a very slow-growing seaweed. It's anchored by a holdfast like the kelps, but unlike the kelps, it only grows a couple of inches each year. And it's interesting that we can actually measure the growth, the annual growth, because ascophyllum or rockweed produces one of these little bubbles or vesicles every year. So on this particular strand, the distance from there to there is 1 year's growth. From on this other strand, from there to there is 1 year's growth. And this frond that I'm holding up here, attached to this rock down here at the bottom, excuse me, is probably about, by measuring the little vesicles, is about 12 years old and has this canopy of branches at the top and the stalk that holds that up in the water column at high tide. So it gives you an idea of the age of these seaweeds in the intertidal. And because of that age, they're really not it's not conducive to any kind of aquaculture of the rockweed. It grows too slowly. It wouldn't be economically feasible. Rockweed forms this shelter of all kinds of the forest for rockweed forms this shelter for all kinds of fish and invertebrates, sea urchins and sea stars and mussels and snails and barnacles and what have you. These are just some examples of the larger invertebrates that you have there. In addition to that, there are all kinds of microinvertebrates like amphipods and isopods and things that are all part of this environment too. There are dozens and dozens of different species that have been documented in these rockweed forests and that are all part of it in the mature rockweed forest. I want to talk a little now about the growth and reproduction of rockweed. Here in late summer, you can see just the vegetative growth of the rockweed in this floating frond here. It grows out as little branches, and they branch dichotomously in many cases at the tips. But in the fall, you have a different kind of branch forming, and these are side branches that produce these little bubbles or receptacles, the reproductive structures of the rockweed. And these little reproductive bubbles or receptacles contain structures that produce the eggs and the sperm for the reproduction of this of the seaweed. And in the early spring, these are released. The gametes, the eggs and the sperm are released into the water column, into the water surrounding the seaweeds. And by so doing, there's this cloud of microscopic food material for various fish and invertebrates and filter feeders that are part of the intertidal habitat. Very few of these gametes actually go on to make new plants. The percentage of them is a fraction of 1% that actually makes new plants. It's overkill, as you might call it, except it produces in this process this burst of nutrients in the springtime. But in addition to that burst of nutrients from the gametes, because the receptacles are deciduous and fall off the ascophyllum branches, they also form in a little bit later in the spring, form this massive amount of organic material. Here in this tide pool, you can see the whole bottom of the tide pool is filled with these receptacles. Here you can see them close up. That's all there is there, just this mass of this organic material that are the deciduous receptacles, kind of like leaves in a forest, if you will. But this is organic richness that is great food for various fish and invertebrates and birds as well. Here are some of the inhabitants that make use of the foraging in the rockweed, not only on the receptacles, but also on the amphipods and other organisms, the smaller microcrustaceans and so forth that are in that seaweed. The eiders, we know, are diving for mussels that are in underneath the seaweed as well. They're particularly fond of mussels, and with mussels being somewhat decimated these days probably by green crabs, the eiders depend on the rockweed forest because that's where mussels are able to withstand some of the predation by green crabs. Now, some of you know that I'm a mycologist, and so I can't avoid telling you this little side story about the association of rockweed Ascophyllum with a fungus. And there is a fungus that grows inside of every frond of Ascophyllum. It's an invisible fungus, if you will. There's no external evidence of it growing there, except when the Ascophyllum reproduces. And when it reproduces, it makes these receptacles, and on the surface of these receptacles, where the Ascophyllum will be making eggs and sperm, the fungus is also making its spores in these little dark structures here that produce spores that are released at the same time that the Ascophyllum is producing its gametes, so that the fungus reestablishes this endosymbiotic association with each new generation. The fungus is thought to be helpful to the rockweed in desiccation tolerance, but we really don't know a whole lot about it. It's not the kind of research that engenders a lot of research support from the federal government. Rockweed continues its value to the marine ecosystem in other ways too. And you've all seen out on the bay, you've all seen great rafts of rockweed drifting in the ocean here. This is rockweed that's either broken off or washed off the beaches, and it may be alive, it may be dead, but it exists as a great clump of biological material that harbors various invertebrates and also shelters fish underneath it that are hiding from predators. And when you see this, you often find it with seagulls and terns and other seabirds clustered around because of all the food that's associated with these drifts. And of course, on the beach, rockweed as this dried up and decomposing beach wrack supports the biological community of amphipods and other microinvertebrates that are growing in this area, and then exist as food for various shorebirds that come along and consume them. So rockweed has other value besides just growing in the intertidal. It also supports many other seaweeds that are not specifically related to it as epiphytes that grow on the surface of the rockweed. And here we have some red algae, porphyra, and one of the red filamentous algae, and also a little filamentous brown alga, Leucista. Here's a red filamentous vertebrata that grows on many Ascophyllum. And then one of the other brown algae, the fucus that we mentioned earlier, can also exist as an epiphyte on the Ascophyllum, particularly in areas where the branches may be broken off or cut off. The fucus seems to be somewhat opportunistic as an epiphyte growing on these surfaces. It's an interesting observation that's curiously obvious when you know what to look for, but very poorly documented. And Allison and I are trying to collect more data on that phenomenon to see if how widespread it is and what the implications of that association are. Ascophyllum grows all through the North Atlantic. Here we are in the Gulf of Maine, near the lower longitudinal extent of Ascophyllum down to New Jersey or so, but it's up in the Maritimes and in Greenland, Iceland, around the British Isles, and on the coast of Norway and even Russia. as well. How much of this is significantly harvested? It's mostly in Iceland and in some of the British Isles and along the Maritimes and in Maine. And the commercial uses of rockweed, just to sum up my part of the talk here, the commercial uses of rockweed are, as it's collected, it's dried and ground into a meal or powder, and often marketed as kelp meal. I'd say erroneously named kelp meal because it's not kelp, actually, it's rockweed, but that seems to be the common name that's used. And this kelp meal is sold as a crop biostimulant, which is non-nutritive, but may in some way protect the crops from salt stress, drought stress, and actually promote root growth and branching by stimulating or adding plant hormones to the system. It can also be sold as a soil conditioner and as a livestock feed supplement. Here's an example of kelp meal for animals, which is, again, ascophyllum. And then as a cosmetic cream, here's seaweed face and body mud, if you want to spend some money on mud. So lots of applications. Probably the biggest commercial application is as kelp meal and for these biostimulants, and there's an increasing worldwide market for that, valued between $250 to $300 million worth of product over the next 4 or 5 years. And it's attractive because it seems to be supposedly sustainable and environmentally friendly. It's not a pesticide or a fertilizer, but rather a stimulant, which may or may not be useful in promoting crop resilience and so forth. And that is the end of the first part of our webinar, and I'm going to turn it over now to Allison. So thank you.
Great. Yeah, thanks, David. So I'm going to share my screen here and start my part of the slideshow, play from start. Let's see. Okay. So, yeah, thank you again for having us to our hosts. And I'm going to focus on the extent and effects of harvesting rockweed with a focus on the Blue Hill Peninsula area. So I'm going to start with an example right in Brooksville, in and around Brooksville, where we've observed rockweed harvesting. So just to make it more real, just show you some photos of it. So on the left, you can see a map of Smith Cove, which is part of Brooksville, right next to Holbrook Island Sanctuary, and Castine is right across the river, across the Bagaduce River. This is a map from Maine.gov. I'm going to show quite a few maps from Maine.gov. The yellow areas are conserved areas. So Holbrook Island State Park is this yellow area here. And then here's another conserved area shown in detail over here, Ram Island, which is owned by Maine Coast Heritage Trust. And I circled Ram Island because we did see a lot of rockweed harvesting there in July this year. And with my little cursor, I'm just going to show you these rockweed beds around the edge of the island in intertidal zone are where the harvesting happens. But mostly I'm going to talk about Smith Cove. And this little triangle here is where the public landing is. And this was the headquarters for some harvesting that occurred in 2022 or 2021. So if you haven't seen them before, one way that rockweed is harvested is with a machine harvesting boat, shown here, with a bag to the side where the rockweed is collected. And the way the rockweed gets into that bag is it's pulled in, sucked in with a vacuum into this rusty-looking contraption on the front of the boat and sucked up the tube into the bag. and shredded. And then on the right, you can see some of these massive bags. They're quite large. They're each about a ton. They float really well because rockweed has a lot of little air bladders inside of it. So this is what harvesting looks like. The boats will go around during high tide and mid tide, collecting rockweed into these bags, sometimes quite close to shore. And on the right, you can see the canopy of an uncut bed in Smith Cove. And then at the bottom right is just example of a handful of rockweed that has been harvested. It's not completely removed. So a good thing is the holdfast is still attached to the rock, but it's shorn off at a certain height depending on where the boat is relative to the tide. The way this works is the bags are brought over to shore. So here you can see on the top left a bunch of these bags of rockweed next to a person, quite tall bags. They're floated at high tide. And this is the launching ramp in the Brooksville town launching ramp there. And then once enough bags are accumulated, a hydraulic lift would come and carry them two at a time over to a truck that would arrive that morning or the day before. And the truck would be filled with 30 to 40 of these massive bags of rockweed. And then the truck this is from a company called Acadian Sea Plants. So they're based in Canada, and the truck would take the rockweed to Canada for processing. So here you can see the truck again and some dates. Because it was at the town landing, there were a lot of people around. We noticed 7 different dates when a lot of bags were removed. So we estimated that over 200 tons of rockweed were taken out that month. Another way that rockweed can be harvested is with a cutter rake. And a cutter rake has these blades and tines and a pole. So people are in an open boat and they reach over and pull it up. It breaks off very easily, and they're mainly getting the top portion of it, putting it into the boat. Then the boat would go to a barge or a dock, and the rockweed is hoisted up into a truck and taken off to dry and process and turn into the products that David was mentioning. So in Maine, we have these sectors. On the left, you can see the Department of Marine Resources has created a sector map for reporting, and harvesters of rockweed and any kind of seaweed have to get a license if they're getting a certain amount, and they are required to report how much they've taken from each sector. So the map on the left, if you ever want to look at it, you can zoom way in on it on any part of the coast. And in the middle here, I've shown with Castine, our area around Smith Cove is sector 413. And to the right, you zoom in even more, and you can see with this sector, the red, which is the rocky ledges where is the best habitat for rockweed to grow. So this is how data are collected on how much rockweed is harvested in the whole coastline of Maine. And this is public information on the DMR website. So you can see the amount on millions of pounds shown on the left here over time, and the estimated value at the dock, usually less than $1 million per year. And so this is just kind of interesting to see how there's been this steady increase, then a drop around 2019, but maybe possibly going back up. So that's just a big picture of like how much rockweed is estimated to be harvested each year. We got more data from these last 2 years to look at that increase and also see where is the rockweed being harvested. So what this slide shows is on the right are the counties along the coast, and on the left, how much has been harvested and reported to the DMR. And this is in tons of rockweed now, not pounds or millions of pounds. And it's easy to see that a lot of it comes from Washington County, where Cobscook Bay is located, and all along here, there's really a lot of good rockweed habitat and a high tide range, large tide range. It's perfect for rockweed. Also quite a lot from Lincoln and Knox County in the middle coast because of the companies that are operating there. And not so much from Hancock County, where we are, and Waldo. In fact, if there aren't at least 3 harvesters, the DMR has to combine the information. They won't send you the information unless there's at least 3 harvesters in each unit that you're looking at. So Cumberland and York are combined, and Hancock and Waldo. So not as much, but still an increase all across the coast. There was an increase between 2022 and 2023. So we also looked in a little more detail at that Hancock and Waldo information. And this is from 4 years. So going back 2020, 2021, big spike, 2022 and 2023. And here it was possible to learn more about how much is from Waldo County, and then the top two colors, green and blue, are from Hancock County. And in fact, Hancock Sector 413 in Smith Cove, the one that I showed you all the bags from, it was about 231 tons reported, which is pretty similar to what we observed. So that just shows you there's a lot of variation in how much rockweed is harvested along different parts of the coast and in different years. So that's helpful information for putting things in perspective. Next, I'd like to go looking at growth and regrowth and following up on some of the points that David made. So the canopy on the left, when it's cut off, it's shorn down to some level, and we want to know how easily does it grow back. And just to remind you, normal growth in the top right is a lot of dichotomous branching at the tips. And then the air bladders, one air bladder per year. So if you take the one plant and spread it out on a table, this is what it looks like, and they're kind of fan shaped because there's so much branching. And this was collected in August. So these little red arrows are pointing to the young reproductive structures that are going to get bigger and fall off, like what David said. So those are not going to branch. And what does branch is at the tips. So they grow at the tips. And I've just circled the air bladders in red so you can see how long it takes. It takes about 6 years for a frond of that size to grow because we see one produced each year. That's a very well-known characteristic of rockweed. So what happens when it's cut? Legally, harvesters can cut down to 16 inches. That's a regulation. Probably it's not often that far down, but it is possible, and that preserves the bottom of the plant so it can regrow from the bottom. And here you see a 4-foot plant. So if we look at the air bladders, these ones here or these lower ones, you can see approximately 2 years of growth. And we can estimate that a 4-foot plant, if it were cut at 16 inches, it might take 10 to 12 years to recover in height, depending on the growth rates, if it's not cut again. So again, very different from the sugar kelp that David was mentioning that would grow its whole length in one winter. This is a very slow growing perennial. Luckily, at the bottom, there are a lot of other branches that haven't grown yet. So when the top is cut off, these lower branches can develop. And they have side branches, and the whole thing can become kind of bushy after it's cut. And there's a lot of studies showing this. So they're kind of more branch. It's kind of like pruning a shrub down, and instead of having a tall tree, you've got a bushier plant or alga. And they can grow back to the point where they could be reharvested within 2 or 3 years, and still the harvester gets a lot of biomass, but they're not returning to their full height that they would have started out as. Sometimes these older cuts, here's some fresh cuts on the left from Ram Island, and here's some older cuts. So the part that's cut off doesn't necessarily regrow. And so they become kind of stunted, and they just kind of sit there, and most of the growth is from newer shoots around the base. Another thing that happens when they're cut on the left here, this is a truncated frond. Here you can see a very large air bladder, but these are the reproductive structures. They make a lot of these, and one little shoot trying to grow there, and here's a fucus attached. But it's not normal at all. So like I said, most of the new growth is going to have to come from other shoots than these cut off ones. And on the right, you can see what healthy growing tips should look like in a rockweed bed. So when rockweed is harvested, it's a patchy result depending on where the boat is drifting and the tide and the weather and how much time the harvester has. So it's really hard it's not clear cut like you might think, like clear cutting a forest. But you can see gaps. So on the right here, you can see some cut fronds and then some canopy in the background. And when we see this patchiness and these gaps, they can fill in over time and grow back. But while they're open like this, light goes down, and that helps the rockweed below grow faster, but it also helps the fucus and other species grow and establish, and it changes the ecology of it when you remove that canopy, and of course it changes the habitat structure. So a question is, how do they grow back, and how would you quantify that? A publication by Ugarte et al., a scientist with Acadian sea plants, just shows that these larger plants that are, and this here is inches, 43 to 50 inches, 51 inches, they are the ones that have the most biomass, which you could sort of tell from the pictures. So those are the ones that are most likely to be harvested. That's the biomass that's valuable there. So I made a chart to sort of illustrate how would you look at this if you wanted to go to a rockweed bed and look at how much was harvested. And so this is like an aerial diagram of a rockweed bed that would be 100 meters long and 30 meters wide. And researchers might put out transects. That's called a transect with some quadrats. And here's a quadrat at the bottom where you would do some subsampling and try to understand how much rockweed was there to begin with, and then what happens after harvesting. So in this hypothetical diagram, you could imagine that these areas in gray would be harvested, and sometimes they would overlap with the transects and sometimes not. That's one scenario. Another scenario is a lot more harvesting. And you can see that there's so much variation in the system that it's really challenging to try to quantify how much is removed, on the ground with some kind of quadrat and transect system. So it's a hard thing to study, really a lot of work. So I think I've given you enough background. I just want to summarize some of the long-term effects that we think about with rockweed, like how much harvesting is going on in each region of the coast, how much biomass of the rockweed is removed each time there's a harvest, and what are they usually the tallest clumps that are being removed, like we think is probably the case. How much regrowth can happen with the biomass and the height over time? Does it take 2 years or 5 years, or how long does it return to its previous state? And what was its previous state? So D would be some never harvested control beds. There are probably a lot of places along the coast of Maine that have been harvested repeatedly, so they don't get to be the highest and largest and oldest that they would if they were unharvested. And that's with a single harvest. We know a lot of places are repeated over time. So how many harvests and what is the time interval? How much is growing back? Those are some questions about just effects on the rockweed itself. And then as far as effects on other species, like other algae, like the fucus or invertebrates or fish, all kinds of species that we know use rockweed, it's very hard to quantify what effects might be happening on a local scale like Smith Cove or a larger scale due to this altered habitat, not having the canopy there and losing all of the rockweed that would be there if it wasn't removed, and the part that would be decomposing as well. So my background is in ecology, and I'm used to complicated systems. And I think this is one of the more complicated systems to try to predict what long-term effects of harvesting might be on other species. And because of this, we think that research is really important, continued research and conservation of the seaweed forests, both the kelp and the rockweed. And there just hasn't been a lot of attention yet that we know of conservation of rockweed in Maine. And with the context of things changing all the time with global warming and ocean acidification and species ranges with changing, different species of algae are coming into the Gulf of Maine. We're just very interested in how the ecology of rockweed might change independent of harvesting and how we can study that and make sure that this important habitat is preserved. I wanted to wind up with some recommended reading, and not for you to take notes or anything, but our website has all of this other information on it. So we have a lot of information. So does the Maine Rockweed Coalition, the Maine Seaweed Council, which is the industry group. And on our website, or you can just look it up separately, there's a fishery management plan that is very comprehensive in terms of the ecology of rockweed and how it should be managed in Maine. This was published in 2014, but it hasn't been implemented yet. And a follow-up to that is a really good article by Hannah Weber and Jessica Mullen and Shep Earhart and others. They publish a paper in the Maine Policy Review in 2023. It's also on our website, or you can just look it up. And it's really a sequel to this other plan of how we could do a better job of harvesting and managing rockweed in Maine. One last thing is, a lot of people ask us, because rockweed is a private property of the upland property owner, this was decided by the Maine Supreme Court in 2019. People ask us, could we protect our property if they own shoreline property? And this is a really complicated issue, but at least with Acadian sea plants, we got a response from Jake Patron, who's the main representative of Acadian. We contacted him after the Ram Island incident, and he wrote back saying that people could send their request to him at infomaine@acadian.canada, and that these notifications of not harvesting, not wanting harvest, would be acknowledged and acted upon, and you don't need to send it in every year. So Acadian is just one of several companies in Maine, but I think it's good that they are acknowledging that people might not want to have their rockweed harvested. Okay, that winds it up. We both wanted to have time for questions. I see we have probably at least 10 minutes, hopefully a little bit longer. So I'm going to stop sharing my screen here.
Excellent. We do have an option for folks who have questions to type in the chat box. And when you open up that chat box, you'll notice that there's a blue 2 box that when you click on that, you can click either the hosts and the panelists or everyone. At least I believe you guys can do that from your location. So anyone who's got questions, feel free to type it in that chat box, and hopefully David and Allison can see it directly. And if not, Noelle and I can convey those questions to you.
The first question I'm seeing is from Tom. Do eiders eat green crabs?
David, that's for you.
No, but I've heard that they make a great bouillabaisse.
The crabs.
Crabs.
Yeah. So eiders specialize on mussels, don't they? And shellfish. I don't know if they eat green crabs.
I don't think so.
Yeah.
Beth, would you like to read the next question?
Sure. Let's see. Question from Mary. Is rockweed recommended as mulch for vegetable gardens? And at what point in the life cycle is it most nutritious?
I don't know that I have a complete answer to that, but I know that lots of people harvest it off the beach for their vegetable gardens. It's easier to access that way than going out and cutting it, and it's beginning to decompose. And I think that partially decomposed makes a lot of sense for a vegetable garden as a mulch or as a nutritive fertilizer as it decomposes. Yeah, it's also good to dig it in if you're going to use it in your garden, because sometimes if it's too fresh, it'll just dry on the surface and it won't decompose nearly as easily.
Nancy asks, I would think that removal of canopies would make the water hotter, allowing more sun in, right?
Well, more light would definitely get in when the canopy is removed, and maybe hotter as well. I guess it depends on, the mixing of the water and with the tide flushing in and out, it may be a temporary change But I don't know. What do you think, David? How to answer that question about temperature?
I don't, I think that's something that could be measured. I don't know that it's
Yeah.
well known.
Yeah,
Yeah.
I mean, remember, rockweed is just in the intertidal fringe, so there's so much other water that's going to be mixing around with the intertidal area that the temperature of the water would be affected by that
It's a good point.
surrounded area.
Our next question is from Patty, and she said, is rockweed an indication of water quality?
I think if it's very polluted, you would notice that the rockweed wasn't as healthy, but I think it would take a lot of pollution to make that because there's so much the presence of rockweed is very much everywhere. And like if you go up some rivers and like I know in Casco Bay, there's a lot of concern about nutrient runoff and whatnot. People have studied what rockweed looks like and how it responds to nutrients, but there's so much of it. I would just say that it's not like calibrating very closely with water quality. What would you say, David?
I think that's probably true. Yeah. As you go up into lower salinity areas, it's not going to be as prevalent, I know.
Mm-hmm. Hopefully people will start noticing it more. Like I used to take it for granted, or I didn't know the difference between rockweed and fucus, but once you start seeing it, it is everywhere. And on more wave exposed areas, it's shorter, and in sheltered bays, it's taller. And it's just, we're so lucky to have it in this whole coast of Maine. That's why people feel like, we're never going to run out. But we are concerned about the taller rockweed forests in the sheltered areas that are the target areas for harvesting.
Well, we have some questions about harvesting coming in. Two that I'm seeing here that kind of go together. Sally asks, are harvesters required to ask permission of landowner, or is the landowner responsible for contacting the harvester to say no harvest? And then Andy, kind of in the same, Andrew, hi Andy, asks, so as a landowner, if a harvester asks permission, do I say yes or no?
David, do you want to tackle that?
Well, it's a little bit muddy because some harvesters feel that incorrectly, I'd say, because of the Ross Supreme Court decision, feel that they have a right to go in and harvest rockweed. But in fact, if we go by the Supreme Court decision that the rockweed is the property of the upland landowner, and permission should be requested. Sometimes harvesters will ask if the landowner has the deed to their intertidal property, and in certain situations, the deed for a property may only go to the high tide line, but I think in most cases it includes the intertidal as well. So in those cases, they should in fact ask for permission. And if a harvester is there and confronted on the shore and is asking for permission, it's your choice as an upland landowner to say, yeah, you can harvest this rockweed. That's fine with me. I think you're doing a good job. Or you can say, no, I prefer that you didn't do that because the habitat along the intertidal is important for me and the organisms that it's sheltering. So it's a complicated issue, but I think that for the most part, permission needs to be requested for harvesting.
Okay, we have a question. How much harvesting is sustainable, and is selective cutting better than clear cutting? And then someone else along that same vein, do you think commercial harvesting should completely stop?
Wow, those are
Right
good
out.
questions. Sustainable. I'm glad someone brought that up because I think you could say harvesting is sustainable if you can do it year after year and the plant isn't dead. It grows back. It's like a field of hay, and it's just keep growing, and you give it a haircut. You could call that sustainable, but I guess it depends on your definition. Like ecologically, people are trying to look at ecosystem-based management and manage the whole ecosystem and all the species in it as much as possible. So we really don't know how much you can take out before certain species are going to start declining that depend on it, and it's very complicated. So that was one part of it. Some people do think that harvesting should stop. They see it as an extraction of a natural resource that is very valuable for the fisheries. Other people think it's a great economic opportunity. You asked about thinning, and I do think there could be ways to harvest rockweed that aren't not as damaging, that just take the top portion, and there's closed areas and open areas. There's a lot of ways it could be managed to be less harmful than the worst case scenarios that we were seeing and reading about and hearing about.
I would say that I think that there ought to be areas along the coast where there's no harvesting allowed, that there be completely conserved areas. But I think it would be almost impossible to suggest that all rockweed harvesting be ceased. That I think that because of the economic push on rockweed harvesting, I think there's always going to be some, but I think it does need to be managed much more rigorously than it is at present.
And if I could just add, can I one more thing? Oh, sorry. I mean, we read that the harvesting companies want to have more management as well. I think there's a lot of room for common ground on more rigorous management. And that's why I listed those management plans on my slide, because it's not like everybody's fighting each other all the time. There could be some common ground there.
David, along with lines of what you had said that you thought that some areas should potentially be left alone and not harvested. What would the criteria for those areas be, do you think?
I think that certainly federal park areas and things like that should be left alone, and I think they are now. I think that there's no harvesting that is allowed on, for instance, Acadia properties and things like that, and harvesters are steering clear of that. But I think the criteria are that the larger, taller, more healthy rockweed forest are ones that should be left alone in those particular areas. And if we find areas that fit those criteria, that would be the ones to choose. You know, in some places it's very difficult to harvest using these mechanical harvesters, and perhaps those areas could be set aside, someplace where there are lots of boulders, for instance, that make it difficult for these harvesting boats to get in and get around.
Let's see. There was one question I saw. Do you consider collection of beach rack that is no longer growing harvesting?
No, I don't. That's not in the same category. But the value, there is ecological value of the beach rack because of the amphipods and the other organisms that are living in it, and because of the shorebirds that are feeding on that. So I think that if we stripped off all of the beach rack, well, probably an impossible task, we would impinge on some of these migratory birds that depend on that. But I don't think that it's in the same category as harvesting.
And since Noelle's got her hands full, I'm going to continue on with questions here. One from Tom is, do you interact with the Maine Rockweed Coalition?
Yes, yeah, we have overlapping goals. So the main Rockweed Coalition is based in Pembroke up on Cobscook Bay. Robin Hadlock Seeley has been leading it for many years, and they are involved in some of these lawsuits. So we share information with them, and we like to learn as much as we can from their experience. But we are an independent group, and our goals are mainly with education and learning ourselves and raising awareness about rockweed and harvesting. That's sort of our focus. Is somewhat different from their focus, I would say. David, do you want to add to that?
No, I think that's a good summary. Thank you.
Okay.
Okay, we've got a couple of longer questions here. One from Edith is, my family has waterfront on Little Deer Isle that used to have a lot of mussels. Several years ago, they granted permission to Acadian sea plants to harvest rockweed, and little by little, the mussel population diminished to near zero this summer. Is there a known correlation between those two things?
As Allison has said, it's a complicated environment. I think you'd have to bring in prevalence of green crabs and many other biological aspects to make any correlation there. Just off the top of my head, I would say that there's probably not a correlation between the harvesting of rockweed and the diminution of mussels, because we see the diminution of the loss of mussel beds in many areas along the coast where there hasn't been any rockweed, for instance, and the conversion of these mussel beds and bars from mud flats where the mussels have grown, where there hasn't been any rockweed. So it's a complicated situation.
Okay.
It is interesting that the green crabs cannot swim, and so they're like on the bottom. And I've noticed sometimes on these rocky crevices that are higher up, the rockweed might actually be protecting the mussels, either from the green crabs or from people taking the mussels, or both. But as David said, it's probably the green crabs are having a much bigger effect than the rockweed, if any.
Than the harvest. Yeah.
Okay, and then I've got a question from Carl. The Department of Marine Resources recently told me that mussel dredgers are allowed to take mussel beds in the intertidal zone without asking the property owner's permission. Is this different from rockweed harvesting?
Yeah. No. Based on the 1647 ruling, or whatever it's commonly called, fishing, fowling, and navigation are public domain activities in the intertidal. And fishing would be, or harvesting of mussels, as well as clams, as well as worms, as well as periwinkles, are all allowed in the intertidal based on that public right. Yeah.
Okay. We also have another question from Sally, I believe. Are there any studies being done to evaluate the effects of harvests on certain areas?
There have been a lot of studies over the years. David, go ahead.
No, I just didn't understand the extent of the question. Maybe you did.
Are there any studies to look at the effects? Could you repeat it again, please?
Sure. I've got to find it again. I'm sorry. Apologies. Are there any studies being done to evaluate the effects of harvesting on certain areas?
There's a lot of research in Nova Scotia and New Brunswick that goes back longer than what we have in Maine. There's been some studies in Maine. They're, in our view, they're usually short-term studies. They're not longer-term studies. So you can always say, oh, we need more research. I think it would be good to have more. I can't put my finger on any certain areas in Maine where the effects are actually being studied long-term. It's all very short-term kinds of experiments.
Okay. And our last question is from Alan. What about wormweed? I understand that's a form of rockweed and is gathered when it occurs in salt marsh. Is there any impact on this harvesting?
Yeah, wormweed is interesting. I'll take that one, David. So if you haven't seen it, it's a floating like mass of looks sort of like rockweed, but not with the air bladders, and they're found in salt marshes and nearby areas. It's thought that the wormweed is good for the salt marsh plants, for the base of the plants, but I don't think there's a ton of research about that. So it's not like the wormweed is a forest or is consequential and common and abundant as regular rockweed. But so it is harvested, and I would imagine that it has less of an impact on other species than rockweed harvesting. But I think there's some benefit to the wormweed where it does grow. Yeah.
But an interesting sort of thought about wormweed is that it's not attached. It's not held in place by a holdfast. And a harvester might argue, perhaps legitimately, that because it's not attached and it's floating, it's perfectly legitimate to harvest it, unlike attached rockweed.
You do need a license to take it and sell it. It's sold for shipping bait around. And some people have said, well, you ship the bait and the rockweed or the wormweed, there might be some invasive species that go with it in some other part of the country, but I don't know much about that.
Okay. And we have one last thing. It's not a question, more of a statement from Robin, and it says, just try to take rockweed off the beach during periods that are not in shorebird migration season. They need it for foraging habitat. And I think that kind of speaks to what you mentioned, to the multifaceted kind of view of rockweed and how it interacts with a multitude of species.
Right.
Good point. Thanks.
Thank you, Beth.
Thank you. And it seems as if we have lost Noelle. I know she was with her little one. So, oh, we have one more question to pop up. We'll do this one and then we'll wrap it up. It says, can Canadian lobster fishermen take lobsters? Oh, I think that says lobsters from Maine. And I don't know that that has much relevance here. And I don't know that you would know that answer.
No idea.
Okay.
I don't know, but I know there's a lot of controversy over all that. Yeah, yeah.
Okay, fair enough. Well, I would like to thank you very much for joining us this evening, Allison and David. I learned a lot. I think everyone else did too. And on behalf of IHT and BHHT, I really want to thank you very much for joining us. And for everyone who is still on with us, we will have a recording up on our YouTube channel within the next few days. And if you have any questions that you think of after the fact, if you send them to info@bluehillheritagetrust.org, we will make sure to get them to Allison and or David and see if we can get you some answers. So thank you very much, everyone, and have a great night.
Yeah, thank you very much. Great.